Let's begin with the task of automatic speech recognition system. Let's look at what is input and output to an ASR system. So our input is audio and our output is the transcript corresponding to audio. As in any machine learning system, we would want to represent our audio into features and then use those features in the machine learning system to generate the transcript. Here is a mental picture of how the features for ASR would look like. So let's say we have an audio signal. We first take that audio signal and divide it into continuous overlapping frames, right? So let's get a bit more into details of that. So as I said, we will take the audio and we would divide into overlapping audio frames. There is a variable called frame window which decides how long each frame would be. So let's say for this example, our frame window is 25 milliseconds. So each of my audio frame is going to be 25 milliseconds. Then we use Fourier transform to convert the audio signal into frequency domain representation. We can think of any audio as summation of many different frequencies, and Fourier transform helps us do exactly that. So it helps us convert the audio signal into the frequency domain representation. We then have something called MEL filters, and the job of MEL filters is to simulate the way human perceives the sound. So humans are better at detecting differences in lower frequencies than higher frequencies. So for example, we would detect a difference between frequency value of 1000 and 1100 Hertz more than 5000 and 5100 Hertz. And these convolution based MEL filters are designed to do exactly that. Let's say if we have n MEL filters, then we would pass the frequency domain representation through these convolution based MEL filters and get the MEL features, right? So for an audio frame of 25 millisecond, if I had n MEL filters, then I would have n MEL features. And then we would take the log of these MEL features to get the log MEL features. So at this point, what we have done is taken an audio frame of 25 millisecond and got n log MEL features corresponding to this audio frame. As I said, we want to have overlapping audio frames, and reason for that is that audio is a continuous signal and we don't want to lose continuity while we are processing future frames, right? And that's why we have overlap. How much overlap would be between frames is decided by another variable called frame shift. So along with the frame window, we have another variable now called frame shift. And let's say the frame shift is 10 millisecond, then my first audio frame would start from 0 and at 25 millisecond. The next audio frame would start at 10 millisecond and at 35 millisecond. So you are shifting by frame shift in every audio frame. And with this, we can compute log MEL features for each of our audio frames. And as I said, these would be n dimensional vectors, and the typical value of n is 80 in practice. Now we have converted our audio into log MEL features. Now let's say we have the log MEL features, then what are the different ways to build automatic speech recognition system? So there are two main paradigms to build ASR system. First is modularized ASR system, where we would have multiple different components such as acoustic model, language model, and pronunciation model. And then we would combine these components together to get a final ASR system. And then there is a non-modularized or end-to-end ASR system where we would have just a single neural network to do the task of ASR or automatic speech recognition.